I'm going to talk about a relatively new mode that appeared pretty much recently, and it's PeakForce Magnetic Force Microscopy, or PeakForce MFM. And we already published recently also the application note dedicated to this mode. So if you want a little bit more in-depth information, you can already find it on our website. And as well, this mode is also listed in our definite AFM handbook, which we also released this year, which is quite cool. I have a copy right here with me, which contains 50 plus different modes, including PeakForce MFM I'm going to talk about. So why PeakForce MFM? So traditionally, when we want to measure magnetic field distribution over the sample, we use tapping mode-based magnetic force microscopy. And it works by acquiring the topography in tapping mode and then lifting up the probe at specific height and looking for the sensing magnetic force distribution over the sample. So however, in this approach, there is actually great benefit of utilizing PeakForce Tapping mode here as well. And here are the few examples. One of them, of course, is to use more sensitive cantilevers, since we can do PeakForce Tapping. So, and the sensitivity, which we detect by, for example, phase shift on the oscillation, is actually will benefit if the probe spring constant gets lower, which we can actually use and benefit here. The second is very much important, of course, is possibility to gain all the nanomechanical properties from PeakForce Tapping QNM, like stiffness, adhesion, energy dissipation. Of course, if you have multiple samples you want to analyze and automate the procedure, also ScanAssist will be great here to automatically adjust parameters on the fly on multiple samples, which is quite nice. And of course, all the sensitivity give possibility to observe very small magnetic objects that probably will be possible to do it before. So quite a few advantages to go into that. So right now, I would also like to show you what I have measured on our Dimension Icon Pro system. And based on its big size, actually, I can place the whole big sample here. Among other samples, we can see I have an open hard drive disk. And right now, using the stage move, I can go to directly location. So PeakForce MFM is already present under the electrical magnetic modes and the lift modes, which you can see here. And I already running it. For now, I'll be using regular MSP probe. However, in our probe database, we have already dedicated new type of probe that I'm also going to mention later and show you later. Right now, since I will be doing PeakForce QNM, and actually I will be interested also in mechanical properties, why not? So I can do quick probe calibration using touch less calibration here and get the deflection sensitivity, which is quite nice and convenient. So again, my position is already defined, so I found a nice spot on this hard disk drive. So using the program move, I can go directly there and to the right position with the accuracy of the motorized stage. So here I can also look at the oscillation of my probe during the lift mode. I can also see and do quick fast thermal tune, so I can see actually the native resonance oscillation of my probe if I need to have a problem finding the right peak, for example, and I can also increase the drive if I need to. So now I would like to go straight to looking at my parameters. So I'll do 10 by 10 micrometer scan size. My scan assist control is fully on, so both force and set point will be automatically adjusted, and my PeakForce tapping amplitude will be on the 50 nanometers, as well as lift height. So right now I'm approaching to my sample of interest. Laser, of course, was already aligned. And right now here I have two channels selected. So the first on the left one will be my topography, and on the right we will have the MFM channel, so the phase shift. So right now the PeakForce tapping optimizing itself, and when it's done, I can already see some signal on MFM channel, and I start the image from the top. Just enable saving it. You can also have the possibility to save the PeakForce capture file here and get all the force distance curve, so that's very convenient as well. Right now, since it's recorded session, so I'll just run it 30 times faster just to not to wait time, and you can nicely clearly see here that I have very nice structure. I have the kind of this grainy structure typical for ferromagnetic materials like steel. And I have this region showing alternating contrast with bright regions with one magnetic moments pointing up towards the tip and dark regions point down to the tip. It's probably not the exactly data stored on this drive, but some kind of region which is also contains some information needed for operating of this drive. I can select the smaller area just to change and look how high resolution I can acquire. The sample is pretty flat, so I can tell you that my Z scale is actually below 1 nanometer. So it's very stable, very nice, considering the tip apex is 50 nanometer tip radius. So I'm getting very nice fine detail right now, 1.1 micrometer scan size of the sample, and I get nice MFM signal here as well. So if I retract right now and open the data in the nanoscope analysis, so here we can nicely go straight to MFM signal. So again, we can nicely look at it, and as already just been mentioned by my colleague, we can also do cross-section. We can look at the profile, size, and measure the width of this magnetic domains, and we can do analysis on them as well. So we can do multiple as well. So you can do line, you can do actually more like a rotating box if you want to average them. I don't do that here, but just to let you know. And of course, this magnetic image that we have right here, we can also bring to topography. So here is our topography height sensor. You can again nicely see the structure with this quiet, so pretty flat. I'm not showing mechanical data because again, sample is pretty hard, so there is no indentation and barely no adhesion to the sample. But here you can see 3D topography of this hard disk drive, which I can right now rotate and position in different angles. And I can also overlay my phase channel, so my MFM channel on top of it, so you can nicely see it right here. So just like that. And as I said, we can really benefit by using dedicated probe, and we have already dedicated probe for PeakForce Tapping MFM, and that's MFM LM. So this probe is way softer, almost 10 times softer than traditional MSP probe, so given higher sensitivity. And of course, this probe also it's also sharper one. So this probe is already available, so if you want to try it, you can just go and check on our website.